This is the review for Concept Quiz 22, Modeling with Exponentials. So the first problem is a car is currently worth $23,000. Its value has depreciated 4.5% per year since it was purchased. Write an exponential expression to represent the value of the car. So we are writing an exponential expression which has the form a times b to the x, where a is the starting value or the initial value, b is our multiplier. So in this scenario, the initial value of the car is $23,000 times our multiplier. We need to look at what's happening percentage-wise. So the car is depreciating by 4.5%. So anytime you have a decrease, a percent decrease, you want to do 1 minus whatever that percentage is. So in this case, it would be 1 minus 0.045. And so our multiplier, just be careful because the multiplier is not actually 0.045. The multiplier is 0.955. And then to the x, however many years has gone by. Alright, so now what was the value of the car 4 years ago? So keyword here is ago. That means 4 years prior to when it was worth $23,000. So our value of x is going to be a negative number because it's in the past. So it will be 23,000 times 0.95 to the negative fourth. And so punching that into the calculator, 23,000 times 0.955 to the power of negative 4. So we can see here that the car was worth $27,651.22. The last question is, how long will it take for the car to be worth less than $1,000? So we're checking, when is this expression going to be equal to $1,000? So in order to solve this exponential equation, we want to first get this exponential part by itself. So I'm going to divide by 23,000. So that I have the 0.955 to the x by itself. Now, in this exponential equation, in order to be able to solve for x without guess and check, we're going to use logs so that we can get the x out of the exponent. So you can reduce this if you want, just so that there's less to punch into the calculator. So it's 1 over 23. So I'm going to do log of the left side and log of the right side. And because of the power property of logs, I'm able to move that x in front. So we have log of 1 over 23 equals x times log 0.955. So then to solve for x, we need to divide both sides of this equation by log 0.955. So those cancel out. So x equals, and then we're going to use the calculator to figure out what that's equal to. So log 1 over 23 divided by log of 0.955 equals 68.1. So after 68.1 years, the car will be worth less than 1,000. So in this case, you could round up and just say 62 or 69 years, since you want the car to be worth less than 1,000. Just don't round down, because at 68 years, it'll still be worth more than $1,000. Alright, now on part B, it's a multiple choice. Which of these expressions represents an investment of $3,257 with a 1.2% annual interest compounded continuously, that's an important word here, for 5 years. So anytime something is compounded continuously, we're using the multiplier E. Remember, E is just a number that's used quite often in nature and in the sciences. So continuously, we can narrow it down to option 3 or 4. The difference between these two is the rate. The rate here is 0.012. The rate here is 1.012. So when we're calculating compound interest continuously, you use the formula P times E to the RT, where R represents the interest rate, not 1 plus the interest rate. So in this case, R is equal to 0.012, not 1.012. So the right answer here is option 3. Okay, letter C here, sketch a graph of the equation, indicate the equation of the asymptote. Okay, we can start this by looking at the locator point. So in this case, HK is equal to 1, -5. Remember to change the sign of the -1. Don't change the sign of the -5. So now, if that's our locator point, we're basically just moving our XY axis to have a new origin of 1, -5. So I'm going to just draw a temporary XY axis here, because the graph has shifted right 1 and down 5. Now to sketch the graph on our new XY axis here, we can change the equation to what it would have looked like if the HK had been 0, 0. So y equals 3 times 2 to the x instead of x minus 1, and there's no k value because it's 0. So if you're sketching this, a sketch is enough, just 2 points. Make a quick table to see what points you would plot. The y-intercept originally, if it was this equation, would be when x equals 0. So 3 times 2 is 6. And if you plug in 1, you get 3 times 2 to the first power. Oops. When x is 0, this is actually 2 to the 0, which is 1. 1 times 3 is 3. And when x equals 1, 3 times 2 to the first power is 6. Now, this is if we had used this equation, but we're already using this new axis where we're assuming this is our 0, 0. So from here, we're going to plot 0, 3, and 1, 6. 1, 2, 3, 4, 5, 6. So our equation looks like this, an increasing exponential function with an asymptote at y equals -5. Alright, last question on here, part D, consider the exponential function passing through 0, 7, and 356. Now here, it might be helpful to make a quick table to see what the pattern is that's happening here. 0, 7, and 356. The function's initial value the initial value here is the 0 term. So the 0 term here is 7. Write the equation in the form y equals a times b to the x. A represents the initial value, so we know that's 7. And I need to figure out what the multiplier is. So fastest way to do this is probably guess and check. What would you have to multiply by to make this table work? So just guess and check. If you multiplied by 2, that would be 14 and 28 and then 56. So I know that I'm multiplying by 2, so that is my multiplier.